Imagine a world without clocks. No ticking hands, no buzzing alarms, no way to know exactly what time it is. Sounds bizarre, right? But this was the reality for many people in China centuries ago. The concept of time as we know it today was almost non-existent. Yet even in this world, a few wealthy individuals could afford to indulge in the luxury of timepieces. These curious baubles, as they were often called, were more symbols of status and wealth than practical tools for telling time. In China, owning a clock was a rare privilege. If a man could afford one, he often owned several. Clocks were not just for telling time. They were collectibles. Imagine a room filled with ornate, intricate timepieces, each a masterpiece of craftsmanship. These clocks were often displayed as works of art, captivating visitors with their beauty and complexity. But using them to mark the hours of the day, that was less common. In a society where public clocks were scarce and few people carried watches, a timepiece was more of a curiosity than a necessity. One Jesuit watchmaker, stationed in the imperial capital of Peking, noted a peculiar custom among the Chinese elite. Gentlemen often carried multiple watches, and they were keen to ensure that all their timepieces were in sync. This obsession with harmony among their watches speaks to the cultural significance of these devices. Even a grandson of the emperor during the time of John Barrow had amassed a collection of at least a dozen watches. However, by the mid-19th century, a British doctor observed that clocks were still a rarity in China, except in public offices. There, it was not uncommon to see a row of half a dozen clocks, many of which were not even in working order. But the story of clocks in China is just one chapter in the broader history of these fascinating machines. The clock, as it turns out, was not just a tool for telling time. It was a revolutionary invention that changed the course of history. It was the mother of machines, laying the groundwork for the Industrial Revolution and the modern world. The clock's journey from a simple timekeeper to a sophisticated machine is a tale of innovation, collaboration, and sheer ingenuity. Unlike many other inventions, the clock did not start as a practical tool with a single purpose. Instead, it evolved through the combined efforts of scientists, craftsmen, and mechanics. This collaborative spirit broke down the barriers between different fields of knowledge, leading to advancements that would shape the future. One of the most significant contributions of the clock was the development of gears and screws. Gears, or toothed wheels, were essential for the functioning of mechanical clocks. The precision required to cut these gears was a major challenge. The first gear-cutting machine was invented by an Italian craftsman named Juanillo Torriano in the 16th century. His machine, which could cut gears with unparalleled accuracy, became the model for later inventions. This innovation was crucial for the mass production of clocks and watches, making them more accessible to the general public. Screws were another vital component. The screw, with its origins dating back to ancient Greece, was a simple yet powerful mechanism. However, making screws with precision was a daunting task. Clockmakers, with their need for precise and reliable components, were at the forefront of screw-making technology. By the 15th century, German clockmakers had developed a lathe that could cut spiral grooves, making it easier to produce screws. This advancement not only improved clockmaking, but also paved the way for other machines and scientific instruments. The lathe, a tool used to shape materials by rotating them on an axis, was another key invention driven by the needs of clockmakers. First, all-metal lathes were created by clockmakers, and were later adapted for various industrial applications. The lathe was essential for the production of gears, screws, and other precision components, making it a cornerstone of the machine tool industry. One of the most significant breakthroughs in clock technology was the introduction of the pendulum. In the 17th century, scientists like Galileo Galilei and Christian Huygens discovered that a pendulum could be used to keep time with remarkable accuracy. This innovation made clocks 10 times more precise than they had been before. However, achieving this level of accuracy required precise gears and screws, which in turn necessitated improvements in the lathe and other manufacturing tools. The collaboration between scientists and craftsmen was crucial in this process. Galileo's observations on the pendulum were put into practice by Huygens, who designed the first pendulum clock. Other scientists, such as Robert Hooke, made further advancements in clock design. Hooke's invention of the balance spring which improved the accuracy of watches, was a significant milestone. These innovations were not just about making better clocks. They were about laying the foundation for a new era of precision engineering. The clock also played a pivotal role in the development of scientific instruments. Clockmakers, with their expertise in precision mechanics, became the pioneers of scientific instrument making. They created a wide range of tools, from sextants and theodolites to microscopes and telescopes. These instruments were essential for navigation, surveying, and scientific research, contributing to the age of exploration and the scientific revolution. The growth of clockmaking as an industry was closely tied to the development of new manufacturing techniques. As clocks became smaller and more portable, the demand for precision components increased. This led to the division of labor, with different craftsmen specializing in specific tasks. By the 18th century, clockmaking had become a highly specialized field, with multiple workers involved in the production of a single timepiece. This division of labor was a precursor to the assembly line production methods that would revolutionize manufacturing in the Industrial Revolution. The spread of clockmaking skills across Europe was another important aspect of this story. In the early days, clockmakers were often itinerant, traveling from place to place to build and maintain clocks. The first large public clocks were often constructed by foreign craftsmen. For example, a clockmaker from Basel built the Strasbourg Cathedral clock in the 14th century, and a German clockmaker made the first clock in the Royal Palace in Paris. This movement of skilled craftsmen facilitated the exchange of knowledge and techniques, leading to rapid advancements in the field. The Protestant Reformation, which swept across Europe in the 16th century, had a profound impact on the clockmaking industry. Many skilled craftsmen, particularly those who had embraced Protestantism, were forced to flee their homes due to religious persecution. Geneva, Switzerland, became a haven for these refugees, and by the 17th century, it had emerged as a leading center of clockmaking. The influx of skilled workers from France, Germany, and other countries transformed Geneva into a hub of innovation and craftsmanship. England, too, benefited from the influx of skilled refugees. In the 16th century, English clockmaking was still in its infancy, with many of the best timepieces being imported from the continent. However, as religious and political upheavals forced skilled craftsmen to seek refuge in England, the local industry began to flourish. By the 17th century, London had become a major center for clock and watchmaking, rivaling Geneva in terms of quality and innovation. The story of clockmaking is also a story of human ingenuity and perseverance. Despite the challenges and limitations of their time, clockmakers continued to push the boundaries of what was possible. They developed new tools and techniques, collaborated with scientists, and adapted to changing market demands. Their work not only improved the accuracy and reliability of timepieces, but also laid the groundwork for the development of modern machinery and scientific instruments. In conclusion, the clock was more than just a tool for telling time. It was a catalyst for innovation and progress. From the intricate timepieces of China to the precision instruments of Geneva and London, the clock played a crucial role in shaping the modern world. Its legacy can be seen in the gears and screws that power our machines, the lathes and other tools that enable precision manufacturing, and the scientific instruments that expand our understanding of the universe. The clock, in all its forms, remains a testament to human creativity and the enduring quest for accuracy and precision.